And in 1976, Trivers and Hare, to kick off our final section on conflict within insect societies, Trivers and Hare measured the average investment in females and males that colonies produced across lots of species, and assessed that against the sex ratio of the colony, and found that the predictions conform to what you would expect under 3-to-1 investment in females to males. So under this circumstance, in these set of species, the workers are winning the conflict. And you would imagine that would be true, because the queen doesn't really have final power over who develops. The workers are the ones that feed the offspring. The workers can go around eating male offspring if they want. So the workers have final say in who gets to develop as reproductive. This paper here is one of those "it ain't as simple as all that" papers, which is quite fun to go and kind of check as a counterpoint to that. But basically, this is the classic demonstration that workers tend to win this conflict. And so that's a classic conflict over sex ratio. This Ratnick et al. Paper this Ratnick et al. Paper is a really nice review of conflict within eusocial societies. And as we've just seen, the degree of conflict, the degree to which the workers' preferred sex ratio depends upon their relatedness to the nestmates. So if the queen is singly mated or not. Whoops, what's going on here? So if you imagine, go away. I just clicked on my own link there. If you imagine a population where some queens mate singly and other queens mate multiply, in the singly mated populations, the workers all want 3-to-1. But in the populations where the queen has mated multiply, there's less conflict. The queen gets to have her 1-to-1 sex ratio that she wants. So within a population, you have a situation where you get something called a tug of war, where you've got singly mated queens over here, where the workers are pumping out 3-to-1, and you've got multiply mated colonies over here, where the workers are pumping out more like a 1-to-1 ratio, and the population sex ratio sits uneasily somewhere in the middle. And given that these workers would like the overall population sex ratio to be 3-to-1, and these workers would like the overall population sex ratio to be 1-to-1, they're pushing against each other, and you get a situation called a split sex ratio, which is where, in order to achieve its 3-to-1 target, but while pushing against the 1-to-1ers, the best thing for these colonies to do is to literally only produce females. And in response, the best thing for these guys to do is to literally only produce males. You have a population where some colonies only produce females and other colonies only produce males. It's an incredibly weird conflict where you get a split sex ratio across colonies within the population. Then you have conflict over who produces the queens. You have, if you have multiple queens within a colony, which happens in lots of ants, you then have lots of different worker matrilines. And it's then a salient question whether workers should favour queens or kind of the production of more reproductives from their own matriline. You'd think that would happen all the time, but demonstrations of that are actually quite rare. One example is this fire ant. We've met fire ants in the green beard gene bit of the altruism lecture, where there are two different matrilines of queens, and one of them is hunted down and killed by workers from the other matriline. So that Keller and Ross describes that kind of green beard gene in the fire ant. Another one is these formica ants, again, where workers will preferentially help queens from their own matriline. There's also conflict over who produces males. One feature of haplodiploidy is that basically, the fertilized eggs turn into females, diploid females, and unfertilized eggs turn into males. And if you're a worker, you never get to mate, but that doesn't mean that you can't produce males. So males come from unfertilized eggs, and workers can normally produce males as much as they like. It's only females that they can't produce. So the question is, should workers produce males? And there's intriguing variation. So among wasps, up to 80% of male eggs come from workers, whereas and at the end of the season, when the queen is a bit decrepit, all of the male eggs get produced by workers. By contrast, in honeybees, a very small percentage of male eggs are produced by workers. Why should that be? Well, okay. When considering this is another relatedness graph, consider this is the relatedness to your sons, the relatedness to sons produced by yourself is always 0.5. The relatedness to sons produced by your mother is always 0.25, according to that relatedness calculation we did. But the relatedness to, and then if we add to this, just to hammer home what this is, oh, go away. The relatedness to males produced by your full sister is always 0.375, and relatedness to males produced by your half sister is always 0.125. You can do the maths with the gamete charts to work that out if you like, but that doesn't depend upon as long as you're sure this is your full sister and you're sure that this is your half sister, that doesn't depend upon mating frequency by the queen. But if you took a random female from the population, the average relatedness to her sons depends on how many times the queen has mated. So mating frequency of the queen is along the bottom here. The more times the queen has mated, the less related you are to an average worker, an average random sister picked out of the workforce. And the more times the queen has mated, the more likely you are to prefer the queen's sons to your sister's sons. So at this point here, if the queen is only singly mated, you'd rather have your sisters produce the sons. Whereas if the queen has mated more than twice, you'd rather the queen were producing the sons than random sisters, because they might not be related to you. So at that point, beyond that threshold of 2 mates, workers begin eating each other's offspring. You get something called worker policing in honeybees, which is that the workers go round eating each other's eggs. This is a survival curve of the percentage of eggs surviving over time, and queen-laid eggs survived quite nicely, but worker-laid male eggs got eaten by other workers. And so honeybees are known for their promiscuity, and this is a case where the workers would rather the queen produced more sisters than their own sisters produced more nephews. Finally, there's conflict over who gets to be queen, and nicely illustrated by queenless ants, where there is a dominant of the females that cooperate. One of them becomes dominant, and then she goes around systematically mutilating the new workers into a non-reproductive state. So she bites their reproductive organs such that they can never become reproductive. Very interesting and quite grim situation where the workers would otherwise have been able to become reproductive, but they can't because the female goes around mutilating them. Another good example is stingless bees, where in stingless bees the queen is much less distinguished from the workers, and the queen, like basically any worker can develop from a larva into a queen if it eats a little bit more. And queens and workers are pretty much the same size, and they can choose their own fate. And the result is that loads of them decide to become queens. They decide to have a go. That results in a tragedy of the commons. So far too many queens develop, more than can possibly be sustained. And so you get these wars among queens, and the workforce is far too small for maximal efficiency of the colony. It would be much better if you had more workers and fewer queens, but each worker is individually deciding to give it a go and have a go at being reproductive. In colonies where they're more related to each other, where the queen is singly mated, much less likely for that to happen. And I'll finish with an interesting article by an incredibly handsome and wise and insightful biologist on the Conversation website, looking at reviewing this intriguing situation in those stingless bees, where some queens produce diploid males, and the workers will go around and kill the queens that produce diploid males because they have a negative effect on the workforce. So there's a very interesting conflict over the production over male production in those species.